Good morning, kids. We're going to talk about some weather variables today. So the first thing I'm going to show you is humidity, how that the heat causes more water to be held in the air. Now I'm going to go ahead and put this on here. First, I'm going to stick this thermometer in this glass to show you the temperature of the water. And the temperature of the water here, let's see if we can get it right there. Temperature of the water looks to be about 70, so 80 degrees. So I'm going to put it over here on this hot plate, and I'm going to let it heat up for just a moment. Okay, as this temperature rises here, we see that the glass is very humid on the inside. You can see the humidity coming up out of there. Thus, we see that temperature affects the ability of the air to hold water. And our temperature on this one is now 160 degrees. So the hotter it gets, the more water will come into the air. Now another thing that will affect weather is wind. So I've got a little bit of wind here, and you saw how the humidity is on the inside of the glass. So wind will come across, and the more contact something has with the air, the effect it will have on the water in the air. Wind will drive ocean currents. It'll also cause more contact with water, which will carry that water away, and it'll end up drying out areas like deserts. You have very dry area in deserts because hot wind has blown across it and pulled all the moisture out of it. You also have very dry areas in the Arctic because the water has frozen out of the air and fallen to the ground. So we have temperature. We know that temperature can affect weather by causing water to rise up into the atmosphere and form clouds. We know that wind can affect weather because wind can dry areas out and it can push clouds around, and you have cold pressure, or you have cold fronts and you have warm fronts, and when the cold touches the warm that's holding the water condenses when the cold water hits it. The cold air hits it and causes it to rain out. I'll show you that here in just a second. Okay, here is the freezer in my stockroom, and notice how the frost is built up around the freezer unit. That's because the air around those cold things, when it froze, the air could no longer hold the moisture in it, and this actually sublimated or came out of the air. Deposited. It came out of the air, and now we have snow. These are ice crystals that have formed. We call it frost, but the air was so cold it could no longer hold the moisture, and so it condensed out and froze on the ice part. Okay, humidity. We know what humidity is. We hear about it all the time. There's water in the air. The air will hold so much water depending on its different temperatures. Humidity is the measure of water in the air. We also have what's called relative humidity. It's the humidity of the air depending on the temperature of the air. This balloon right here, these different balloons represent different temperatures. This blue balloon would be a cold temperature. This yellow balloon would be a warmer temperature. And this orange balloon would, of course, be a higher temperature, a hot day. Each one of these balloons has roughly the same amount of water in it. They all have about the same amount. But this one is 100% full of water. The relative humidity of this balloon inside here, if this is representing a certain air temperature, is 100%. Why? Well, because it's 100% full of water. There's no air in here. Let all the air out, tied it off. So the humidity, the relative humidity inside this one is 100% because it is holding all the water it can hold. The next one, the relative humidity of this one is about 50%. It's holding about 50% of the volume of this balloon is water. The rest of it is air. So I would say that the relative humidity inside this balloon is 50%. This balloon can hold even more water. It's larger, it's blown up. It's about 25%. Let's say this balloon could probably hold this much water four times. So it's about 25% full. So the relative humidity of this balloon is 25%. Let me show you an example of how this affects the way it feels outside. This balloon right here, you can see is less than 25%. If this was some air that was warmer, it's holding a certain amount of air, it can hold more. There's a certain amount of water that this can hold, and it can hold more than what's in here. But as the temperature cools, it can hold less air. So we're going to represent cooling by letting air out of the balloon. So that it can, notice the percentage of water inside the balloon is increasing, not because there's more water, but because it can hold less. Now we're about 25%. We're about half now. Let me see if we can see this. So you can tell this balloon has about half, it's holding about half the water that it can hold. So its relative humidity is about 50%. Notice what happens as we get down to 100%. At 100%, now this balloon has no air in it, it's all water. Beyond that, just like the air outside, if the temperature cools or the balloon shrinks, what happens? As the balloon shrinks, it can hold less water. What begins to happen? The same thing that happens outside. When the air can no longer hold the water that's in it, it begins to precipitate. It's still at 100%. Why? Because the air is shrinking, and it cannot hold the water that's in it, so the water falls out. After the water's all come out, if the air heats up again, now the air is going to be fairly dry. Now the relative humidity is 0. No matter how big the balloon is, because it has no water in it. Doesn't matter whether I have a big balloon or a small balloon, the relative humidity is 0 because there's no water in it. Let's see how this affects dew point. For dew point, our sponge is going to represent the air. It's very dry, kind of hard, like a sponge you might pull out of a new package or one that's been sitting behind the sink or something. It's dry. There's no water in this sponge. So let's say some dry air picks up a little bit of moisture. Now it's got some. The air can hold so much water, just like a sponge can hold so much water. But when the sponge gets to the point where it can't hold any more water, just like the air, when it gets to a point where it can't hold any more water, it's at 100%, 100% humidity. Any more, it begins to fall out. So by squeezing this sponge, it's going to demonstrate the cooling of air. As the air cools, water begins to come out of it. Outside in the evening, this is dew point. It depends on how much water there is in the air. Relative humidity will affect the dew point. What is dew point? That's the point where the dew forms. So if you have more water in the air, dew point is going to occur at a higher temperature, right? If you have less water in the air, dew point will occur at a lower temperature. Notice I'm going to have to squeeze this more in order to be able to start getting water out of it. So it depends how much water is in the air. That affects how much or what dew you get, what the temperature is like outside. So in a dry area like the Ozarks in Missouri in the summertime, you may wake up in the morning on a cool morning and have the ground very dry because the air was dry and it never reached its dew point. However, in Florida, where the air is always wet because we live next to the ocean, if you wake up on a cool morning, you're going to find water all over your car outside because dew point was higher and it cooled down and caused the water to condense out of the air onto your car. And if it's cold enough, it freezes there and then you have to scrape it off. Okay, so this has been our a few demonstrations on temperature, humidity, relative humidity, dew point, wind, and we didn't cover pressure, but you know that when pressure increases, like a can of soda, I've got one right here. The pressure inside this can is great. That's why the gas is still dissolved in here. When I release the pressure, what happens? It begins to fizz. Begin to get fizz coming out of it. You put your face down there, you can hear it crackling. What is that crackling? That's bubbles of gas coming out of the liquid, and it's little tiny bubbles popping at the surface of the liquid. So if we had this, pour a nice soda. Very nice. But if I let it sit at this low pressure in this room, all the gas is going to come out of the Coke, and then it's going to be flat. So the pressure that was sealed inside here kept the Coke from going flat. When I release the pressure on the liquid now is the same as in the outside of the room, and the pressure, the gas that is dissolved inside the liquid begins to go down. This is the reason why airplane cabins are pressurized, so that when you are taken up to a very high altitude, the gas doesn't bubble out of your body. Or why a diver, when he's down in a very deep depth, doesn't come up really fast. He has to come up slowly so that the gases that are dissolved in his blood and in his body don't bubble out. Pressure affects weather. Temperature affects weather. Humidity affects weather. Relative humidity, dew point, all these things are weather variables. Y'all have a good day.